Welcome back to my channel, and welcome again to the Managing Safety Climate Survey course. In this video, we will begin Module 5, Analyzing and Understanding Results from a Safety Climate Survey. The aim of this module is to help you interpret safety climate survey data using appropriate analysis techniques. In particular, we will look at how methods such as the T-test and F-test can be applied to identify trends, patterns, and key insights within the data. Beyond the statistical analysis, this module also focuses on interpretation. You will learn how to translate survey results into meaningful and actionable recommendations. These recommendations can then be used to improve workplace safety practices, enhance employee engagement, and strengthen the overall safety culture within the organization. By the end of this module, you should be able to move beyond simply reading survey results, and instead use them to support informed decision-making and continuous improvement in health and safety performance. In this section, we will create a raw data table in Microsoft Excel to prepare the information for statistical analysis. First, set up the basic structure of the worksheet. In column A, enter position. In column B, enter respondents, and in column C, enter ID. These columns help to classify and identify each respondent. Next, input the questionnaire items into the worksheet. From column D to H, enter questions 1.1 to 1.5, which correspond to the Health and Safety Management System construct. From column I to M, enter questions 2.1 to 2.5 for workplace condition. From column N to R, enter questions 3.1 to 3.5 for workers' safe behaviors. Finally, from column S to W, enter questions 4.1 to 4.5 for management's attitudes, values, and beliefs. After entering the questionnaire items, calculate the total scores for each construct. In column X, label it Total Score of Health and Safety Management System, and apply the formula equals sum, D3. In column Y, enter Total Score of Workplace Condition, with the formula equals sum, I3. In column Z, enter Total Score of Workers' Safe Behaviors, with the formula equals sum, N3, and in column AA, enter Total Score of Management's Attitudes, Values and Beliefs, with the formula equals sum, S3. To apply these formulas for all respondents, simply copy the first row downward to the remaining rows. Next, calculate the squared total scores. In column AB, enter Square Total Score of Health and Safety Management System, using the formula equals X3X3. In column AC, enter the squared total for Workplace Condition using equals Y3Y3. In column AD, use equals Z3Z3 for Workers' Safe Behaviors, and in column AE, use equals AA3AA3 for management's attitudes, values, and beliefs. Again, these formulas should be copied down for all rows. For classification purposes, 3 position groups are created: Senior Management Team, Middle Management Team, and Person at Work. The Senior Management Team includes roles such as Managing Director, General Manager, Production Director, and Engineering Director. The Middle Management Team includes Production Manager, Engineering Manager, EHS Manager, Production Engineer, Engineering Engineer, and EHS Engineer. The Person at Work group includes Production Supervisor, Engineering Supervisor, and Workers 1 through 7. In real safety climate surveys, the respondents column should not be included to ensure confidentiality, and only IDs should be used. However, in this e-book, the respondents column is included to make the process easier to understand. At this stage, Your raw data Excel sheet should now be fully structured and ready for analysis. To make the Excel sheet more engaging and easier to understand, I have entered raw data from an actual company that I previously surveyed. The system has then automatically calculated the results based on the formulas we set up earlier. As shown in the table below, the data is now fully processed, with total scores and squared scores generated for each construct. This allows us to move beyond just raw responses and begin observing patterns within the dataset. With this completed dataset, we are now in a position to perform statistical analysis and start interpreting the results in a more meaningful way. This section introduces the basics of data interpretation. When people are first presented with large amounts of raw data, it is common to feel overwhelmed by its size and complexity. However, in statistics, we simplify and make sense of such data by using key summary measures such as the mean, standard deviation, and variance. These measures allow us to take a helicopter view of the data, meaning we focus on the overall patterns rather than getting lost in individual data points. In Module 5, we apply these techniques to better understand what the data is telling us as a whole. The mean refers to the average value of a set of numbers. It is calculated by adding all the values together and dividing by the total number of values. The mean gives us a central value that represents the dataset. The standard deviation measures how spread out the data values are from the mean. If the standard deviation is small, it means the values are close to the average. If it is large, the values are more widely spread. The variance is closely related to standard deviation. It is the average of the squared differences from the mean and shows the overall level of variation in the data. In fact, variance is essentially the square of the standard deviation. Together, these three measures help us interpret large datasets more effectively and form a clearer understanding of the results. In this section, we will prepare and interpret the data analysis within the Excel file. First, we create a structure for summarizing the data. In cell A4, enter cumulative freq. Cumulative frequency refers to the running total of frequencies up to a certain point in a dataset. It shows how many responses fall within or below each response option. For example, if option 1 has 2 responses, option 2 has 3, and option 3 has 5, the cumulative frequency would be 2, then 5, then 10. This helps us understand how responses accumulate across the scale. Next, in cell A9, enter frequency. Frequency refers to the number of times a specific value or response appears in the dataset. For instance, if 10 respondents select option 1, then the frequency for option 1 is 10. In column B, we label the response options by entering the header, response option, and listing the values from 1 to 5 beneath it, representing the Likert scale. To calculate frequencies, we use the frequency function. For example, in cell C4, we enter equals at frequency, raw data, $3.21, data analysis, $B4. This formula calculates how often each response option appears for question 1.1 in the specified range of the raw data sheet. We then adjust the reference for each subsequent row, so B5, B6, and so on, to capture all response options from 1 to 5. We repeat this same approach across all questions by adjusting the column reference. For example, in D4, equals at frequency, raw data, $3.21, data analysis, $B4. In E4, update the column accordingly. This ensures that each question is properly analyzed based on response distribution. Next, we organize the results by grouping questions 1.1 to 1.5 under the Health and Safety Management System section, with total score placed in column H. The same structure is repeated for workplace condition, workers' safe behaviors, and management's attitudes, values, and beliefs. To compute frequency differences, we use a simple subtraction method. For example, in cell C10, we enter equals C5 C4. This is then repeated for cells C11 to C13, and across columns D to G, to complete the frequency table. Finally, we calculate key descriptive statistics. In column A, we list the following measures, and in column C we apply the corresponding Excel formulas. Mean is calculated using equals average, raw data, D3, representing the average value of the dataset. Median is calculated using equals median, raw data, D3, which identifies the middle value when the data is sorted. Mode is calculated using equals mode. SNGL, raw data, D3, which shows the most frequently occurring value. Range is calculated as equals max, raw data, D3, min, raw data, D3, representing the spread between the highest and lowest values. Variance is calculated using equals var. S, raw data, D3, which measures how widely the data is dispersed around the mean. Standard deviation is calculated using equals STDEV. S, raw data, D3, which shows the average deviation from the mean. Finally, the number of respondents is calculated using equals count, raw data, D3, which tells us how many valid responses were included in the analysis. We then repeat this entire process for columns D to G, ensuring that each question is analyzed consistently using the same statistical methods. Using the example raw data entered earlier, the Excel data analysis sheet will appear as shown in Figure 5.2.1. From the completed analysis, it can be observed that 19 participants responded to the survey, resulting in a 100% response rate. There were no missing responses, as all participants completed the questionnaire carefully. This ensures that the dataset is complete and reliable for further analysis. Looking at the overall mean scores across the four constructs, management's attitudes, values, and beliefs recorded the lowest average score at 13.42. In comparison, workplace condition achieved the highest mean score at 21.63, followed by workers' safe behaviors at 15.42, and the health and safety management system at 13.63. These results suggest that priority areas for improvement include management commitment, the overall safety management system, and employee safety behaviors. In terms of variability, the range values indicate differences in opinion among respondents. The health and safety management system shows a range of 19, workers' safe behaviors a range of 16, and management's attitudes a range of 18. In contrast, workplace condition has a much smaller range of 4. A higher range indicates greater diversity in responses, meaning there is less agreement among participants. These findings are supported by the standard deviation results. The Health and Safety Management System, 6.02, Workers' Safe Behaviors, 5.72, and Management's Attitudes, 6.37, all show relatively high variation in responses, while workplace condition shows much lower variation at 1.54. A higher standard deviation indicates that responses are more spread out from the mean, reflecting differing perceptions among respondents. Therefore, more detailed analysis is required for the health and safety management system, workers' safe behaviors, and management's attitudes to identify which groups hold differing views. It is also important to note that safety climate surveys measure perceptions rather than actual safety culture. For example, senior management may believe their safety attitudes are strong, while workers may perceive them differently. This highlights that perception and actual culture are not always aligned. When analyzing results by position group, the mean total scores for the health and safety management system show clear differences. Senior management scored 22.3, formula equals average, raw data, x3, middle management scored 15.0, formula equals average, raw data, x7, and persons at work scored 8.89, formula equals average, raw data, x13. This indicates that senior management views the system more positively, while workers rate it significantly lower. For workplace condition, the average scores are relatively consistent across groups. Senior management at 21.5, formula equals average, raw data, y3, middle management at 22.17, formula equals average, raw data, y7, and persons at work at 21.33, formula equals average, raw data, y13. This suggests general agreement across all levels regarding workplace conditions. For workers' safe behaviors, the results differ more noticeably. Senior management scored 9.5, formula equals average, raw data, Z3, middle management scored 11.17, formula equals average, raw data, Z7, while persons at work scored 20.89, formula equals average, raw data, Z13. This indicates that workers rated their own safety behaviors much more positively than how management perceived them. Finally, for management's attitudes, values, and beliefs, senior management scored 22.5, formula equals average, raw data, R3, middle management scored 15.7, formula equals average, raw data, R7, and persons at work scored 7.89, formula equals average, raw data, AA13. This shows a clear perception gap, where management rates themselves highly, while workers perceive management attitudes much less positively. Overall, this analysis highlights important differences in perception across organizational levels and identifies key areas where safety climate improvements are needed. Based on the results obtained so far, further statistical testing such as the F-test is required to conduct a deeper level of analysis. The F-test is a statistical method in which the test statistic follows an F distribution under the null hypothesis. It is commonly used to compare different statistical models fitted to a dataset, or more simply, to determine whether there are significant differences between group means. In the context of this safety climate survey, the F-test helps us assess whether the differences observed between groups, such as senior management, middle management, and persons at work, are statistically significant or whether they may have occurred by chance. In other words, the F-test allows us to move beyond descriptive statistics and determine whether the variations in perceptions across different groups are meaningful. This makes it a useful tool for validating whether the observed differences in safety climate scores reflect real differences in viewpoints within the organization. By applying the F-test, we can better understand the strength and significance of the differences identified in the earlier analysis, and use this information to support more informed conclusions and recommendations. In this section, we conduct the initial F-test analysis considering responses from all participants across all categories. The purpose of this F-test is to determine whether there are significant differences in perspectives regarding the four key constructs: health and safety management system, workplace condition, workers' safe behaviors, and management's attitudes, values, and beliefs. To begin, an F-test Excel worksheet should be created to organize the required statistical outputs. In column A, we list the key statistical measures as follows: total score mean, total score median, total score mode, total score range, total score variance, total score standard deviation, sample size, sigma x squared, n. The term sigma x squared, n, sigma x squared, n, refers to the sum of the squared values of all individual scores divided by the total number of observations. In this expression, sigma x squared means each score is squared and then summed, while n represents the total number of data points. This value is useful in variance and standard deviation calculations. For example, if the scores are 2, 4, and 6, then squaring each value gives 4, 16, and 36. The sum of these values is 56. Dividing by the number of observations, 3, gives 18.67. Next, in column B, label the section as Health and Safety Management System. Column C is labeled Workplace Condition, column D is Workers' Safe Behaviors, and column E is Management's Attitudes, Values, and Beliefs. We then input the relevant Excel formulas under each category, starting with the Health and Safety Management System column. The mean is calculated using equals average, raw data, x $3.21. The median is calculated using equals median, raw data, x $3.21. The mode is calculated using equals mode, raw data, x $3.21. The range is calculated using equals max, raw data, x $3.21, min, raw data, x $3.21. The variance is calculated using equals var, raw data, x $3.21. The standard deviation is calculated using equals STDEV, raw data, x $3.21. The sample size is calculated using equals count, raw data, x $3.21. Finally, sigma x squared, n is calculated using equals SUM, raw data, x $3.21, sum, raw data, x $3.21, B9. The same set of formulas is then applied to the remaining constructs: workplace condition, workers' safe behaviors, and management's attitudes, values, and beliefs, by adjusting the cell ranges accordingly. This ensures a consistent statistical comparison across all categories, forming the basis for further F-test interpretation and analysis. Next, we continue building the F-test calculation in Excel by extending the analysis across all elements. In cell G4, we calculate the term representing the combined contribution of all constructs. The formula is equals SUM, raw data, x3, sum, raw data, x3, sum, B9. This formula takes the total sum of scores across all constructs, squares it, and then divides it by the total number of samples. It serves as an important component in the calculation of group variation. Next, in cell G7, we compute the squared total score of all elements using the formula equals sum, raw data, AB3. This represents the sum of squared totals across all constructs, which is required for further variance decomposition. We then proceed to construct the ANOVA-style F-test table using the following formulas: DF group, equals count, B9, minus 1. df error, equals B14 B12. df total, equals, sum, B9, minus 1. ss group, equals sum, B10, G4. Serra, equals B17 B15. ss total, equals G7 G4. ms group, equals B15 B12. m Serra, equals B16 B13. f test, equals B18 B19. p-value, equals FDIST, B20, B12, B13. In statistics, df refers to degrees of freedom, which represent the number of independent values that can vary in a dataset without violating any constraints. Degrees of freedom are essential in determining the correct distribution for hypothesis testing. Finally, the f-test value and p-value allow us to evaluate whether there are statistically significant differences between the group means. A smaller p-value typically indicates stronger evidence that meaningful differences exist among the constructs being analyzed. Here are some common examples that help explain the concept of degrees of freedom in statistical analysis. In a sample variance or standard deviation calculation, the degrees of freedom are typically n1, where n is the sample size. This adjustment is used because one parameter, the mean, is already estimated from the data. In a t-test, degrees of freedom vary depending on the type of test. For a one-sample t-test, the degrees of freedom are also n1. For an independent t-test comparing two samples, the degrees of freedom are based on the combined sample sizes, typically calculated as n_1 plus n_2 to 2, depending on the assumption of equal variances. In a chi-square test for independence, the degrees of freedom are calculated using the formula R1, C1, where R represents the number of rows and C represents the number of columns in the contingency table. These degrees of freedom are important because they determine the correct statistical distribution used in hypothesis testing. They also help identify critical values and calculate p-values accurately. Next, we look at the concept of sum of squares, SS, which is a key component in ANOVA and other statistical methods. The total sum of squares, SS total, measures the overall variation in the dataset around the grand mean. It is calculated as the sum of the squared differences between each observation and the overall mean. In simple terms, it represents the total variability present in the data. The between-group sum of squares, SS group, also known as SS between, measures how much variation exists between different group means. It shows how much of the total variation can be explained by differences between the groups rather than variation within the groups. It is calculated based on the differences between each group mean and the grand mean, weighted by the number of observations in each group. Together, these concepts form the foundation for understanding ANOVA, where total variation is decomposed into variation explained by group differences and variation due to random error. The third component is Serra, also known as SS within or SS residual. This measures the variation within each group, meaning it captures how much individual data points differ from their own group mean. In other words, it reflects the random or unexplained variation that remains after accounting for differences between group means. The formula for Serra is based on summing the squared differences between each observation and its corresponding group mean. Conceptually, it represents what is left over once group-level differences have been explained. Together, The three components of variation in ANOVA are connected through a fundamental relationship. SS total equals SS group plus SERA. This equation shows that the total variation in the dataset can be decomposed into variation explained by differences between groups, SS group, and variation within groups, SERA. This decomposition is the foundation of ANOVA. From these sums of squares, we then calculate the mean squares by dividing each sum of squares by its respective degrees of freedom. MS group equals SS group, DF group M SERA equals SERA, D FERA. These values are then used to compute the F statistic. F equals MS group, M SERA. The F-test itself is used to compare variances or test whether there are significant differences between group means, particularly in ANOVA or regression analysis. In simple terms, the F-test answers the question, are the differences between group means larger than what we would expect by chance alone? In the context of ANOVA, the F statistic is interpreted as follows. If F greater than 1, the variation between groups is larger than within groups, which may indicate a significant difference. If F approximately equals 1, the variation between groups is similar to within groups, suggesting no meaningful difference. If F less than 1, it usually indicates that group differences are not meaningful and may be due to random variation. Overall, the F-test provides a structured way to determine whether observed differences between groups are statistically significant or simply due to chance. To determine statistical significance, the F statistic is compared to a critical value from the F distribution. This critical value is determined using two sets of degrees of freedom, one for the numerator, between groups variation, and one for the denominator, within groups variation. Based on this comparison, we can determine the corresponding p-value. The F-test is commonly used in several situations. ANOVA, to test whether three or more group means are significantly different. Regression, to test whether the overall regression model provides a good fit to the data. Equality of variances, to compare whether two populations have similar variances. For example, in an ANOVA test, suppose the calculated F value is 5. We then compare this value to the critical value from the F distribution with df1 equals 2 and df2 equals 30. If the resulting p-value is less than 0.05, we reject the null hypothesis, meaning that not all group means are equal and at least one group differs significantly. The p-value represents the probability of obtaining a test statistic as extreme as the observed result, assuming that the null hypothesis is true. In simpler terms, it tells us how likely it is that the observed differences occurred purely by chance. A smaller p-value indicates stronger evidence against the null hypothesis, while a larger p-value suggests that the observed differences may be due to random variation. In general, p is less than or equal to 0.05, statistically significant result. Reject the null hypothesis. P greater than 0.05, not statistically significant, fail to reject the null hypothesis. It is important to note that the 0.05 threshold is commonly used, but it is not universal. Some fields may adopt stricter thresholds such as 0.01, or more relaxed ones such as 0.10, depending on the level of rigor required. In an F-test such as ANOVA, after calculating the F statistic, the p-value is obtained from the F distribution using the corresponding degrees of freedom. This allows us to formally evaluate whether the differences between group means are statistically meaningful or simply due to chance variation. If the p-value is small, it suggests that the differences between group means are statistically significant. For example, suppose the p-value is 0.011. This means there is only a 1.1% probability of observing such differences among groups if, in reality, all group means are equal. Since 0.011 is less than the commonly used significance level of 0.05, we reject the null hypothesis. In other words, we conclude that at least one group mean is significantly different from the others. To summarize, a small p-value provides strong evidence against the null hypothesis. A large p-value indicates weak evidence, meaning the observed results are still plausible under the null hypothesis. From the Excel F-test sheet, specifically the section analyzing all elements without considering respondent groups, the F-test results indicate that there are no statistically significant differences across the elements. However, this result should be interpreted with caution. Based on the mean scores of the four constructs, workplace condition appears to have a noticeably higher score, while the other three constructs fall within a similar range of approximately 13 to 15. This suggests that differences may exist that are not fully captured by the overall F-test. Therefore, while the initial F-test suggests insignificant differences among all elements, a more detailed analysis is required. In this case, a t-test is recommended to further examine differences between specific groups or constructs and provide a more precise understanding of where significant differences may exist. Next, an F-test was conducted to examine whether there were significant differences in perceptions of the health and safety management system among the three respondent groups: senior management, middle management, and persons at work. The computation was carried out as shown in the preceding table. The F-test compares the variation between the groups with the variation within the groups to determine whether the mean responses differ significantly. Based on the results, the calculated F-value exceeded the critical value, and the significance level was found to be less than 0.05. Therefore, the null hypothesis that all groups share the same opinion is rejected. The findings indicate that there are significant differences in opinions among senior management, middle management, and persons at work regarding the health and safety management system. However, while the F-test confirms that a significant difference exists somewhere among the groups, it does not identify which specific groups differ from one another. Therefore, further analysis using t-tests is required to conduct pairwise comparisons between the groups. These comparisons will help determine whether the significant differences occur between senior management and middle management, senior management and persons at work, or middle management and persons at work. The results of the t-tests are presented and discussed in the following section. Next, an F-test was conducted to determine whether there were significant differences in perceptions of workplace conditions among the three respondent groups: senior management, middle management, and persons at work. The computation was carried out as presented in the preceding table. The purpose of the F-test is to compare the mean responses of the three groups and assess whether any observed differences are statistically significant. Based on the results obtained, the calculated F-value did not exceed the critical F-value, and the significance level was greater than 0.05. Therefore, the null hypothesis cannot be rejected. The findings indicate that there are no significant differences in opinions among senior management, middle management, and persons at work regarding workplace conditions. This suggests that the three groups share relatively similar perceptions of workplace conditions within the organization. A review of the mean scores further supports this conclusion. The mean values for senior management, middle management, and persons at work are closely clustered within the range of approximately 21 to 22, indicating a high degree of consistency in their responses. Since the F-test has shown that there is no statistically significant difference among the groups, there is no requirement to conduct further pairwise comparisons using t-tests. Consequently, the analysis concludes that perceptions of workplace conditions are generally aligned across all respondent categories. Next, an F-test was conducted to determine whether there were significant differences in perceptions of workers' safe behaviors among the three respondent groups: senior management, middle management, and persons at work. The computation was carried out as presented in the preceding table. The F-test was used to compare the mean responses of the three groups and evaluate whether the observed differences in opinions were statistically significant. Based on the results obtained, the calculated F-value exceeded the critical F-value, and the significance level was found to be less than 0.05. Therefore, the null hypothesis that there are no differences in opinions among the respondent groups is rejected. The findings indicate that there are significant differences in opinions among senior management, middle management, and persons at work regarding workers' safe behaviors. This suggests that the three groups perceive workers' safety-related behaviors differently within the organization. However, while the F-test confirms the existence of a significant difference among the groups, it does not identify which specific groups differ from one another. Therefore, further analysis using t-tests is required to perform pairwise comparisons between senior management and middle management, senior management and persons at work, and middle management and persons at work. The results of the t-tests will provide a more detailed understanding of the nature and direction of these differences and are presented in the following section. Next, an F-test was conducted to determine whether there were significant differences in perceptions of management's attitudes, values, and beliefs among the three respondent groups: senior management, middle management, and persons at work. The computation was carried out as presented in the preceding table. The F-test was used to compare the mean responses of the three groups and assess whether the differences in opinions were statistically significant. Based on the results obtained, the calculated F-value exceeded the critical F-value, and the significance level was found to be less than 0.05. Therefore, the null hypothesis that there are no differences in opinions among the respondent groups is rejected. The findings indicate that there are significant differences in opinions among senior management, middle management, and persons at work regarding management's attitudes, values, and beliefs. This suggests that the three groups have differing perceptions of management's commitment, values, and beliefs related to workplace safety and organizational practices. However, while the F-test confirms that a significant difference exists among the groups, it does not identify which specific groups differ from one another. Therefore, further analysis using t-tests is required to conduct pairwise comparisons between senior management and middle management, senior management and persons at work, and middle management and persons at work. The results of the t-tests will provide further insight into the specific group differences and are presented and discussed in the following section. Following the F-test results, further analysis is conducted using t-tests to examine pairwise differences between the groups for the construct management's attitudes, values, and beliefs. As previously explained, the F-test indicated that there are significant differences in opinions among senior management, middle management, and persons at work regarding this construct. However, the F-test does not identify which specific groups differ from each other. Therefore, t-tests are required to perform detailed pairwise comparisons between the three groups. This will help to determine where exactly the significant differences lie, whether between senior management and middle management, senior management and persons at work, or middle management and persons at work. The purpose of this further analysis is to provide a clearer understanding of how each stakeholder group perceives management's attitudes, values, and beliefs, and to identify any statistically significant differences in their views. The results of the t-tests are presented in the following section for further interpretation. A t-test is a statistical hypothesis test used to determine whether there is a significant difference between the means of two sets of data. The test assumes that the test statistic follows a t-distribution when the null hypothesis is supported. In simple terms, a t-test is used to analyze whether there is a significant difference between two groups at a time. It is most appropriate for pairwise comparisons. Following the results of the f-test, if a significant difference is identified among multiple groups, t-tests are then conducted to further determine exactly which pairs of groups are significantly different. Based on the f-test results, the first t-test is carried out to examine whether there is any significant difference between the elements under the construct, understanding the key traits of a positive safety culture. Although the f-test indicated that there were no significant differences between the elements, caution is still considered in interpretation. This is because the mean value for the workplace condition element is the highest among the three elements, which suggests a potential variation in perception that may not be fully captured by the f-test alone. Therefore, further pairwise analysis using t-tests is organized to provide a more detailed comparison between the elements. To ensure that t-test analysis is conducted systematically and comprehensively, pairwise comparisons are performed between all key elements of the health and safety framework. The analysis begins by taking health and safety management system as the baseline element and comparing it against each of the other three constructs: workplace condition, workers' safety behaviors, management's attitudes, values and beliefs. Next, workplace condition is compared against the remaining two elements: workers' safety behaviors, management's attitudes, values and beliefs. Finally, a direct comparison is made between workers' safety behaviors and management's attitudes, values and beliefs. This structured approach ensures that all possible combinations of pairwise comparisons are fully examined. For each t-test computation, the following statistical components are required: mean difference, pooled variance, standard error, SE, degrees of freedom, DF, t-statistic, t-test value, p-value. These values allow us to determine whether the differences between each pair of elements are statistically significant or due to random variation. Pooled variance, also called pooled estimate of variance, is a method used to combine the variances of two or more independent groups into a single estimate, assuming that the groups have equal or nearly equal population variances. Pooled variance is most commonly used in a two-sample t-test involving independent samples, where it is assumed that the two groups have the same population variance. This assumption is also known as homogeneity of variance. For two independent samples, the pooled variance is calculated using the formula S_p squared equals n_1 minus 1 S_1 to the power of 2 plus n_2 minus 1 S_2 squared n_1 plus n_2 minus 2, where n_1, n_2 are the sample sizes. S_1 squared S_2 to the power of 2 are the sample variances. The term pooled is used because the variances from both samples are combined together to form a single, more reliable estimate of variability. This is useful because each sample alone only provides a partial estimate of the population variance. For example, if two groups are given and their variances are combined using the formula, the pooled variance may result in a value such as 5.1. Standard error, or SE, refers to the measure of variability or precision of a sample statistic, such as the mean. In simple terms, the standard error tells us how much a sample estimate is likely to vary from sample to sample. It is essentially the standard deviation of the sampling distribution, showing how far the sample mean is expected to be from the true population mean. 1. Standard error of the mean, SEM. The most common type is the standard error of the mean, or SEM. It is given by the formula SHE equals S square root n, where SIS the sample standard deviation, NIS the sample size. In this case, a larger sample size results in a smaller standard error. This means that as the sample size increases, the estimate becomes more precise, and the standard error decreases. Pushpin 2. Standard error of the difference between means. For two independent samples, the standard error is calculated as SHE equals square root S underscore 1 squared, N underscore 1 plus S underscore 2 squared, N underscore 2. This is commonly used in two-sample t-tests to determine the variability between two group means. Pushpin 3. Standard error of a proportion. The standard error for a proportion is given by SHE equals square root p 1 minus p n, where pi is the sample proportion. This is used when dealing with proportions rather than means. Bar graph. Why is standard error important? Standard error is important because it is used to build confidence intervals. For example, estimate plus or minus z dot operator SHE. It is also widely used in hypothesis testing, including t-tests and z-tests. A smaller standard error indicates a more reliable and precise estimate. Pushpin standard deviation versus standard error. Standard deviation measures the spread or variability of individual data points within a dataset. Standard error, on the other hand, measures how much a sample statistic, such as the mean, is expected to vary from sample to sample. In simple terms, standard deviation describes data variability. Standard error describes estimate precision. Upon completion of the formulation inputs, the results of the t-test shall be presented in a structured tabular form. The table will display the key statistical outputs for each pairwise comparison, including the mean difference, pooled variance, standard error, degrees of freedom, calculated t-value, and corresponding p-value. These results will then be used to determine whether there are statistically significant differences between the respective groups being compared. A typical output format of the t-test results is shown as follows. The mean values for each group are tabulated as shown. Based on the mean values obtained, it is observed that there are clear differences in perception between the three groups, particularly between senior management and persons at work. In summary, there is a need to improve the health and safety management system, workers' safety behaviors, and management's attitudes, values and beliefs in order to close the perception gap and strengthen the overall safety culture within the organization. 4.2 T-Test. Perception from respective designation on the four elements of safety culture. 4.2.1 T-Test on health and safety management system. The next test is conducted to analyze whether there is any significant difference in opinion between senior management, middle management, and persons at work regarding the health and safety management system. To begin with, descriptive statistics are computed for each group. These include mean, median, mode, range, variance, standard deviation, and number of respondents. By this stage, the formulas used are already familiar, and the results are presented as per table. Following the descriptive analysis, t-tests are performed to determine whether there are significant differences between the groups in their perception of the health and safety management system. The pairwise comparisons are carried out between senior management and middle management, senior management and persons at work, middle management and persons at work. The results of the t-test indicate that there are differences between senior management, middle management, and persons at work in terms of perception of the health and safety management system. The most notable difference is observed between senior management and persons at work. The mean score for senior management is 22.25, while the mean score for persons at work is 8.89. This indicates a substantial gap in perception between top-level management and operational-level employees regarding the effectiveness and implementation of the health and safety management system. 4.2.2 T-test on workplace condition. The next test is conducted to analyze whether there is any significant difference in opinion between senior management, middle management, and persons at work regarding workplace condition. To begin with, descriptive statistics are computed for each group, including mean, median, mode, range, variance, standard deviation, and number of respondents. The results are presented as per table. Following the descriptive analysis, t-tests are performed to determine whether there are significant differences between the groups in their perception of workplace condition. The pairwise comparisons are carried out between senior management and middle management, senior management and persons at work, middle management and persons at work. The results of the t-test indicate that there are insignificant differences between senior management, middle management, and persons at work in terms of perceptions of workplace condition. This suggests that all three groups share relatively similar views regarding workplace conditions within the organization, with no statistically significant variation observed between their responses. 4.2.3 T-test on work behaviors. The next test is conducted to analyze whether there is any significant difference in opinion between senior management, middle management, and persons at work regarding work behaviors. To begin with, descriptive statistics are computed for each group, including mean, median, mode, range, variance, standard deviation, and number of respondents. The results are presented as per table. Following the descriptive analysis, t-tests are performed to determine whether there are significant differences between the groups in their perception of work behaviors. The pairwise comparisons are carried out between senior management and middle management, senior management and persons at work, middle management and persons at work. The results of the t-test indicate that there are insignificant differences between senior management and middle management in terms of perceptions of worker behaviors at work. The average scores for these two groups fall within the range of approximately 9.5 to 11.17, indicating a relatively similar perception between both groups. However, the results also indicate that there are significant differences between senior management, middle management, and persons at work in terms of perception of worker behaviors. In particular, persons at work indicated in the survey that they generally behave safely, whereas senior and middle management rated their behaviors lower. This demonstrates a clear perception gap between management and workers regarding safety behavior in the workplace. 4.2.4 T-test on management's attitudes, values and beliefs. The next test is conducted to analyze whether there is any significant difference in opinion between senior management, middle management, and persons at work regarding management's attitudes, values, and beliefs. To begin with, descriptive statistics are computed for each group, including mean, median, mode, range, variance, standard deviation, and number of respondents. The results are presented as per table. Following the descriptive analysis, t-tests are performed to determine whether there are significant differences between the groups in their perception of management's attitudes, values, and beliefs. The pairwise comparisons are carried out between senior management and middle management, senior management and persons at work, middle management and persons at work. The results of the t-test indicate that there are significant differences between senior management, middle management, and persons at work in terms of perceptions of management's attitudes, values, and beliefs. Senior management rated themselves highly in terms of attitudes, values, and beliefs related to health and safety, while middle management rated themselves at a moderate level. However, persons at work rated management significantly lower in this aspect. This indicates a clear perception gap across the organizational hierarchy, with the most critical view coming from persons at work regarding management's commitment to health and safety values and beliefs. Thank you for participating in Module 5, Analyzing and Understanding Results from a Safety Climate Survey. In this module, we focused on interpreting safety climate survey data using appropriate statistical techniques such as the F-test. The aim was to identify key trends and insights, and to understand how these findings can be translated into meaningful, actionable recommendations. These recommendations help improve safety practices, enhance employee engagement, and strengthen the overall safety culture within the organization. With Module 5 now completed, we are ready to move on to the next stage of the safety climate assessment process.